Okay, ladies and gentlemen, we are going to do lesson 7.4, parallel lines and proportional parts. We are starting with theorem 7.5, triangle proportionalities theorem. Please find this on your paper. It states that if a line is parallel to one side of the triangle and intersects the other two sides, then it divides the sides into segments of proportional length. Meaning, so in this picture we have BC. It's a line that touches two sides and is parallel to the third side. What happens is we now are able to say this segment AB makes a ratio with BC. So it's the large to the small part. Instead of what we're used to is going from AB to the whole length. We don't have to do that anymore because of theorem 7.5. So now, if we look at this picture, we've got PS, which is 12.5. We've got RS, which is 5. We got PT, which is 15. And TQ, we have no clue what it is yet. So we can use theorem 7.5, the triangle proportionality theorem, to write our ratio. Like I said before, we're used to taking this small piece proportional with the larger piece. We don't have to do that anymore. We just need to take this piece, PS, and we can make a ratio with SR. And then we're going to take PT to TQ. Now we can fill in what we've got. We've got 12.5 to 5 is equal to 15 to x. Cross multiply. 12.5x is equal to 5 times 15. So 12.25x is equal to 75. Divide by 12.5. And x equals 6. So therefore, TQ is equal to 6. So TQ equals 6. So, different way to write a proportion than we've used in the past. Moving on. Theorem 7.6. This is the converse. So in theorem 7.5, we went from knowing two parallel lines to writing a proportion. Now in this one, we're going to go from the proportion. If the proportions is equal, then the two lines are parallel. So the two lines that we are talking about, are they parallel, are DE and GH. So therefore, we need to look at the proportions of FG to DG is that equal to, we're going to go from FH to EH. So, in our problem it says that DG is half the length of GF. So I have no clue what GF is, so I'm just going to put that as X. My DG is half of that, so 1/2 X. I know that EH is 6, and I know that HF is 10. Set it up. So FG was X, DG is half of X, which is equal to 10 to 6. I'm going to cross multiply. So 6x is equal to 1/2 x times 10. So 6x is equal to 5x. Are they equal? Absolutely not. So therefore, DE is not parallel to GH because the proportion was not equivalent. Moving on. So theorem 7.7, this is the triangle mid-segment theorem. Think back to a trapezoid. Don't write this. Think back to your trapezoid. When we had to find this mid-segment, I added base 1, I added base 2, and I took half of that. So I added base 1 plus base 2, and I divided it by 2 to get my midpoint. So I'm dividing it in half. So keep that in mind. So this says a midsegment of a triangle is parallel to one side of the triangle, and its length is half the length of that side. So in this picture, here is your midsegment, here is the side of the triangle. So what it's stating is that JK is equal to half of FG. So it's half of that side length. So in our picture, we are going to find DE. So here is DE. What side of the triangle does that correspond with or parallel to? To AC. So if DE is the midsegment, then DE is going to equal 1/2 of AC. Well, what's AC? It's 15. So DE is equal to half of 15, which is 7.5. So it's just half the length. Okay. In 3B, we're going to find DB. Problem. So, erase this. So now we're looking at DB. Now DB is part of the side of the triangle. So instead of just using DB, I'm going to use that whole length of AB. So the side of the triangle, what segment inside the triangle is parallel to that? Well, that's FE. Those two are parallel. So if they're parallel, according to the midsegment, that FE is equal to half of AB. So if I apply what I did the other time, FE is 9.2, half of AB is equal to 9.2, so therefore AB would have to be 18.4. Now, if this whole length is 18.4, notice that these segments AD and DB are congruent, then I only need half of it. So DB is equal to half of AB, so therefore DB is also 9.2. That's one way to do it algebraically. We'll discuss on Friday another way. So 3C, finding the angle measure. So I am looking for angle FED. So I'm looking for this angle. Now, what two lines do you think need to be parallel to deal with this angle? Well, you should use FE and you should use AB. If those two lines are parallel, so I'm going to say that FE is parallel to AB. If they're parallel, cut by this transversal DE. So DE is my transversal. AD is my transversal. Then what type of angle is this and this one? They are alternate interior angles. So therefore, the measure of angle FED is also 82 degrees. If you want to think about it, think about alternate interior angles. So that's how you use the triangle mid-segment theorem to find different pieces of the triangle. Moving on. Here is corollary 7.1, which states proportional parts of parallel lines. If three or more lines are parallel, intersected by two transversals, then they cut off the transversals proportionately. Meaning, if you look at this, we've got 3 lines that are parallel. We've got transversals. Then what's happening is you're not making congruent segments, you're making proportional segments. So what it's saying is we can take AB and it would go with BC. Those two would be proportional to EF to FG. Or you could have went BC to AB, and then you would have to do it in the same order, FG to EF. They're proportional. So now, if we look at this figure, I know that Davis, Broad, and Main are all parallel. I've got transversals here and here. So now I need to come up with a proportion. I need to come up with 2 ratios. So I can use 15 to X. And then on the other side of that, those parallel lines, using the other transversal, I can use 24 and 8. Cross multiply and solve. So 24x is equal to 8 times 15. So 24x is equal to 120. So divide by 24. So x is equal to 5. So the distance between Broad Street and Main Street is 5. Moving on. Here is now dealing with some congruent parts. Corollary 7.2 says congruent parts of parallel lines. If 3 or more parallel lines cut off congruent segments, so these segments are congruent, on one transversal, then they cut off congruent segments on each transversal. So, once again, you've got parallel lines. Then you've got these transversals. What's happening is, over here on this side, it made a set of congruent segments. What do we do with congruent segments when we're trying to find something? We set them equal. When they're congruent, they're equal to each other. So I can take 4a minus 5 and set it equal to 3a plus 6. You guys know how to solve that. If you solved it, a would have equaled 11. On the other side, because what it's stating is, if this segment is congruent to this segment, then that makes this segment and this segment congruent. Same on my picture. If these two are congruent, then it makes these 2 pieces congruent. So I can set them equal to each other and solve it. So I would take 3b, set it equal to 5/3, 5/3 b plus 2 and solve it. When you solve it, b was equal to 3/2 or 1.5. Okay? Using that same concept, we can come up with proportions when we're dealing with word problems. I'm trying to find out what is the ocean front zone, how much yardage is that on lot A. So you've got triangle, you got some parallel lines. So these lots make up some parallel lines. There's 3 of them. I can come up with a proportion. So I have this length and this length. I can make that a proportion, or a ratio to get to my proportion. 58 to 42. Then I can use, I have no clue what that is. We'll make that x to 60. Cross multiply and solve. So 58 times 60 is equal to 42x. Solve it. You end up with x as being, I believe, 82.9. And that's yards. So 82.9 yards for lot A. If you need to, go back and review the video. What I would like you to work on now are the 6 problems on the back of your, 4 problems are on the back of the first sheet and the bottom 2 problems on the second sheet. And we will review this again on Friday. Have a good day. Talk to you on Friday.